I will continue with subtopic 1.1 Atoms and Molecules. For the second learning outcome, B. Interpret mass spectrum. There are two types of relative mass, which are relative atomic mass, the symbol is AR, and relative molecular mass with the symbol MR. The actual mass of atom is very small, which is in range of 10 to the power of negative 20 kg. Hence, relative atomic mass is used. Definition of relative atomic mass is ratio of the mass of an atom is compared with 1/12 of mass of one carbon-12 atom. Or, in the form of formula, relative atomic mass of X is equal to average mass of one atom of X divided by 1/12 multiplied with mass of one atom of carbon-12. The carbon-12 isotopes is chosen as the reference standard for comparing the masses of other atoms because it is a solid and easily available. Relative atomic mass is a ratio, hence it has no unit. The formula of relative molecular mass is relative molecular mass of Y equal to average mass of one molecule of Y divided by 1/12 multiplied with mass of one atom of carbon-12. Or, relative molecular mass of Y is the sum of the relative atomic masses of all the atoms shown in the molecular formula. As an example, the relative molecular mass of methanol with molecular formula CH3OH is equal to relative atomic mass of carbon plus 3 multiplied with relative atomic mass of hydrogen plus relative atomic mass of oxygen plus relative atomic mass of hydrogen. After that, insert all of the relative atomic mass value. Finally, the relative molecular mass of methanol is 32. Relative molecular mass also has no unit. There is a tool called mass spectrometer. Mass spectrometer is used to determine relative atomic mass of an element, relative molecular mass of a compound, types of isotopes that are found in the naturally occurring element, including the abundance of the isotopes and its relative isotopic mass, and used to recognize the structure of the compound in an unknown sample. A record of the separation of ions in a mass spectrometer is called a mass spectrum. It is a mass spectrum of ion. Let's reinterpret the mass spectrum. The spectrum consists of relative abundance against mass m over charge E. The number of peaks are the types of isotopes occurred. According to the mass spectrum, there are 4 peaks present. Therefore, there are 4 isotopes of iron, which are iron 54, iron 56, iron 57, and iron 58. The height of each line is the isotopic abundance of each isotopes, which is amount of each isotope, also known as relative abundance. Relative abundance of iron 54 is 5.82%. Iron 56 is 91.66%. Iron 57 is 2.19%. And iron 58 is 0.33%. Relative abundance exists in form of ratio or whole number or percentage, which is total percent is equal to 100%. The ratio of M over E for each species known as isotopic mass. Let's recalculate the relative atomic mass or relative molecular mass values. To calculate the relative atomic mass, we will use the formula relative atomic mass of X is equal to average mass of one atom of X in unit AMU or U divided by 1 over 12 multiplied with mass of one atom of carbon 12 in unit AMU or U. Therefore, we need to find the value of average mass of one atom of X by using formula average atomic mass is equal to sum of Qi multiplied with Mi divided by sum of Qi, which are Qi is the relative abundance of an isotope of the element and Mi is the isotopic mass of the element. Unit for average atomic mass is AMU or U. Next, substitute the value of average mass of one atom of X in the formula of relative atomic mass and substitute the value of mass of one atom of carbon 12, which is 12 AMU. Finally, we get the relative atomic mass of X. How about the calculation of relative molecular mass? By using the same formula to calculate of relative atomic mass, we just change AR to MR and change average mass of one atom of X to average mass of one molecule of X. It is the correct ways to calculate average atomic mass of an element. Given to you the mass spectrum of M, according to the mass spectrum, there are three isotopes of M. Average atomic mass of M is equal to sum of Qi multiplied with Mi divided by sum of Qi. Let's calculate the average atomic mass. Sum of Qi multiplied with Mi is equal to X multiplied with A plus Y multiplied with B plus Z multiplied with C divided by the total abundance X plus Y plus Z. Average atomic mass has unit U, which is same with the unit of mass in the mass spectrum. Please remember that relative atomic mass and relative molecular mass are dimensionless. In the other words, no unit. But atomic mass and molecular mass have unit, atomic mass unit, or in the short form is AMU, or unit U. For the next part, I will continue with subtopic 1.2, mole concept. Thank you.